Hey, what's up? It's Jake from Nimbus DevOps, and I'm here today to talk to you about set types. So, we have two set types in Python. One is called set, and the other one is called frozen set. So, the set type is mutable, while the frozen set is immutable, cannot be changed. They're unordered collections of immutable objects, and will introduce the concept of hashability. So hashability is a characteristic that allows an object to be used as a set member or as well as a key for a dictionary, and you'll find that out pretty soon. And the official documentation says that an object is hashable if it has a hash value that never changes during its lifetime, and it can't be compared to other objects. So you can use it as a dictionary key because it never changes. It also can be a set member because the data structures use the hash value internally. Most of Python's immutable objects are hashable. Mutable containers like lists and dictionaries are not, but immutable containers like tuples and frozen sets can be hashable, but only if their elements are hashable. Objects where instances have user-defined classes are hashable by default, and you can compare them. Their hash values derived from the ID, if you ever need to know how to compare that. So objects to compare equally have to have the same hash value. Sets are commonly used to test for membership. So in this video, we're going to introduce the in operator, and I'll show you how we do that now. So let's say we want to make a set of prime numbers. So I'm going to say primes equals set, and I'm going to create an empty set. Okay, so if I type primes, it returns a set of nothing. But let's say I want to add some numbers to it. So I'd say primes.add 2, I'm going to add 3, I'm going to add 5, and I can look at my primes and see a set denoted with curly braces as 2, 3, and 5. And notice the empty set just returns set with parentheses, not these curly braces. So let's say I want to add the number 1. Well, 1 is technically not a prime number. So, I mean, you can remove it with primes.remove 1, and it will remove it. Now, if I just look at primes, see that it's gone. So you can add and remove things from a set with just .add.remove. And you can also test for membership. And when I say test for membership, I can say 3 in primes. And what I'm really saying is 3 in the prime set? And we say that that's true. We can also check for the number 5, or you can check for the number 4, which is not in there, so it should be false. Yep, there we go. And you can also use the operator not in, right? So in case 4 is in primes is false, so 4 not in prime should be true. And it is, because 4 is not in primes. So you notice that we have the values 2, 3, and 5. So what happens if I try to add 5? Or, if I add 5 again, primes.add 5. Then what happens? Primes. You'll notice that it didn't add another 5 because 5 is already there. It's already a member of this set. So it's not going to work because duplication is not allowed in this set. So let's say I want to add to this. I'm going to make a bigger primes different set, and I'm going to say the set to that. And if you want to do more, you just make like a list inside of it, and I can say 5, 7, 11, 13, and close it out like that. And now I have a bigger primes. So if I wanted to make a list 2 through 13 of primes, I can use what's called a union operator, and I can say take the primes, and then that's the union of bigger primes, right? And now I have 2, 3, 5, 7, 11, 13. I can also use the intersection operator, which is the and sign, and I can say primes and bigger primes. And you'll notice that they both have 5 in them, right? There's 2, 3, 5, and then there's 5, 7, 11, 13. So the intersection is at 5, so we can see that it does have an intersection. And I can also do primes minus bigger primes, and you can see the difference there. And it's just different ways to create a set and manipulate it and adding and removing things, you know. Some of this might work for you, some of it might not work for you. I mean work for you, like your use case or whatever. But we did try to add duplication to emphasize that you can't duplicate in a set. And if we tried it with an immutable counterpart, you're going to see a totally different result. So let me clear this screen here, and let's make small primes. So small primes, and this time we're going to use the frozen set. So frozen set, and we'll do 2, 3, 5, 7. Okay, so now I have a frozen set called small primes. And then let's do big primes. So big primes will be 5, 7, and 11. Okay, a little bit of overlap there. So those are my big primes. Oops, no, I want big primes to be a frozen set of this. Okay, so let's see what happens if you try to add something to a frozen set. So let's take, let's say I want to take small primes dot add, and I just want to add 11 to it. You get an error. Attribute error. Frozen set object has no attribute add. And that's because frozen sets, you cannot add or remove. You can't change them, right? And so that it's frozen. It's exactly what it is. It's just frozen, right? Union is allowed. Intersection, union, stuff like that is allowed. But frozen sets are very limited with respect to their mutable counterpart of just regular sets. They still provide very effective membership tests, so you can do like 5 in what I call it, big primes. So you can still do membership tests with this. You can still do unions, intersection, difference operations, and whatnot. But it is important to know what is a set and how does that differ from a frozen set? Which one's mutable? Which one's immutable? And how do you add and remove numbers? And we learned the in operator, the not in operator, and then learning about the operators for union and looking for intersections. So those are things that you may come across. And so I just wanted to cover those two concepts in a very short video. So if you have any questions about sets or frozen sets, let me know. But if not, I'll leave you to it.